today we're going to work on dividing radicals. And part of that is a process called rationalizing the denominator, which we will get into shortly. But first of all, just look at dividing radicals. The same rules can apply for multiplication. So if I take something like 2 root 8 divided by root 2, I divide the coefficients, so 2 divided by, well, there's nothing there, so 1. So that remains a 2. And then divide the radicands. 8 divided by 2 is 4. This becomes 2 root 4. And what's the square root of 4? 2. So it just becomes 2 times 2, or 4. So that one simplified quite a bit. If we look at part B, 12 root 6 divided by 4 root 3. Well, 12 divided by 4 is 3. And then divide the radicands. 6 divided by 3 is 2. That one just becomes 3 root 2. You can't simplify it any further. Because 2, the radicand, is not a perfect square, nor does it have a perfect square factor. So it just stays as is. That's kind of the simplest way to divide radicals. But if we look at the next one, 4 divided by 2, that's 2. 3 divided by 6, yeah, it's 1/2, right? So it actually becomes root 2 on the bottom, because you kind of reduce 3 and 6 to 1 and 2. That's not fully simplified though. And the reason is that you can't divide 2 by 2, right? Because one's a coefficient, one's a radicand. You can't do that. But it just has to do with the rules of what constitutes a simplified radical. And there are a few things that you already know to look for. Like you can't have a perfect square or a perfect square factor in the radicand for it to be simplified, right? That's why when you look up above here, this was not simplified. Because 4 is a perfect square. That radicand has a perfect square factor, so you have to keep going. That's one thing to look for. Another thing to look for is that you can't have a radicand in the denominator of a fraction for it to be fully simplified. And this one has a radicand in the denominator. So here's what it says. For a radicand to be fully simplified, the radicand must contain no perfect square factors. That part you already knew, but this is a new part. The radicand must have no fractions, so that's why I couldn't just make it a 1/2. And no denominator can contain a radical. So this, even though I did that simplifying by dividing and got 2 over root 2, is not fully simplified. And that's where the new stuff comes in, which is called rationalizing the denominator. So now we need to figure out, how do we further simplify 2 over root 2? We need to get rid of that radical. And we're going to do that by multiplying.
Multiply root 2.
Right. If we multiply root 2 by root 2, what do we get? Root 2 times root 2. Root 4, which is equal to just 2, because it's a perfect square. So that's the idea that we're going to use here. If you multiply a radical by itself, then you get a number that's not a radical. And so in this question, 2 divided by root 2, to simplify it, I want to multiply that denominator by root 2. So that it'll turn into a root 4 or a 2. But is it okay to just randomly do that? Multiply something by root 2? We have to do it to both the top and the bottom, right? If I multiply by root 2 over root 2, then it's okay to do that. Because what's root 2 over root 2 equal to? 1. Yeah. And if you multiply something by 1, it doesn't it stays the same. It doesn't change its value. And so what I'm going to do is multiply by 1, because it's okay to do that whenever you want. It doesn't change the value. You could take all the money in your bank account right now, multiply by 1. That's fine, right? Still the same. Unfortunately, you can't like multiply it by 10 or something, right? Out of the blue. But you can multiply it by 1 because it doesn't change the value. So that's what I have to do. When you're doing this, you need to make sure what you're multiplying by is equal to 1. And the way to do that is just make sure you're multiplying the top and the bottom both by the same thing. But if I just put a 1 there and say multiply by 1, it's not going to do anything. So I use this particular one that's root 2 over root 2, because that's going to change the way that it looks. Yeah, this becomes, on the top, 2 times root 2, so 2 root 2. And on the bottom, root 2 times root 2, which is root 4 or 2. So it's 2 root 2 over 2, or actually that can simplify further, can't it? 2 root 2 over 2, and then the 2's cancel, and it's just equal to root 2. What should I multiply by in the second question there to simplify it? It's 2 root 3 over root 5.
Root 5.
Right, I need to multiply that by root 5 over root 5. And when I do that, on the top I get 2 root 15. And on the bottom, it's root 25, which is just equal to 5. So 2 root 5 over 5. That's 2 root 15 over 5. That's fully simplified because the radicand doesn't have a perfect square factor, and now there's no radical in the denominator. That's what you're looking for to know that it's fully simplified. We need to be able to simplify this. And the problem is that you have that radical in the denominator. We need to multiply by something to get rid of it. To take a binomial like that and multiply by a radicand that will make the answer just into a whole number, we need to multiply by the conjugate of the denominator. And the conjugate is just the same thing, but with an opposite sign in the middle. So for this one, I'm going to multiply by root 2 plus 7. It was root 2 minus 7. We'll multiply by root 2 plus 7. And if I do that in the denominator, what do I have to multiply the numerator by? Same thing, root 2 plus 7. These are conjugate binomials, root 2 minus 7 and root 2 plus 7. They're the same, but one has a plus and one has a minus. And now when I start doing that multiplying, well, the numerator will be 4 root 2 plus 28, because I did 4 times root 2 and 4 times 7. And then the denominator, root 2 times root 2 is root 4. Root 2 times 7 is 7 root 2. Negative 7 times root 2 is negative 7 root 2. And then negative 7 times 7 is negative 49. As I simplify that, 4 root 2 plus 28, looking at that whole denominator, the square root of 4 is 2, so I'll change that first term into a 2. The two middle terms cancel each other out. 7 root 2 and negative 7 root 2. That's what we wanted to have happen, right? Is get rid of the radicals in the denominator. And then I have just a minus 49 left. So this will be 4 root 2 plus 28 over negative 47. Often when the denominator is negative, we'll just switch that negative to the numerator. So we have negative 4 root 2 minus 28 over 47. So I just switched the signs of everything, which is okay to do in a fraction because it's still equivalent. It's just, it's not like this first one is wrong. It's just convention says we usually don't leave a negative in the denominator. So have a look at this one, and I want you to think about what will we have to multiply it by. So this one we're going to multiply by root 6 minus 4, because the denominator is root 6 plus 4. And we'll do that on the top and the bottom. 3 root 5 times root 6 is going to be 3 root 30. And then 3 root 5 times negative 4 is negative 12 root 5. In the denominator, root 6 times root 6 is root 36. And then we have a negative 4 root 6 plus 4 root 6 minus 16. So 3 root 30 minus 12 root 5. I can't really do anything with the denominator, with the numerator at this point because there aren't any perfect square factors, so I'll just leave it as is. The denominator, the root 36 changes into a 6. The two middle terms cancel each other out, and then we have negative 16. So we have 3 root 30 minus 12 root 5 over negative 10. Or we could write that, this is the way that this one would probably be written. 12 root 5 minus 3 root 30 over 10. So switch the signs of them all. The 3 root 30 becomes negative, the negative 12 root 5 becomes positive, and the negative 10 becomes positive. I have one more that I want us to do. So we're going to multiply in the numerator and the denominator by 4 plus 5 root 5. This is going to be a lot because it's a binomial times a binomial on the numerator and the denominator, but I'm sure we can do it. So we're going to take root 5 times both of those things in the numerator. We'll get 4 root 5 plus 5 root 25. And then we'll do 2 root 2 by both of them, so it becomes 8 root 2 plus 10 root 10. And that's just the numerator. Then we'll do 4 times 4 is 16 plus 20 root 5 minus 20 root 5 minus 25 root 25. This seems like it has a fair bit of simplifying to do. That first term, 4 root 5, can't be simplified, so we'll leave it. The second term can be simplified because 25 is a perfect square. So this turns into 5 times 5, or 25. 8 root 2 can't be simplified. 10 root 10 can't be simplified. In the denominator, 16 stays as it is. The two middle terms cancel out, and then we have minus 25 times 5. So 4 root 5 plus 25 plus 8 root 2 plus 10 root 10 over 16 minus 25 times 5, 16 minus 125, right? Negative 109. And I'm out of space, so I'm actually just going to leave my answer like that with the negative in the denominator this time. Like I said, it's good to switch it, but it's not necessary.